So, hello everyone, my name is Alexander Nozick from MIPT and JetBrains Research, and today I'm going to give an workshop, an example how to build your own Kotlin Jupyter plugin. I won't go into the details of how the inner workings of those things. What I want to tell you today is how to build your plugin from scratch, and we will do it just in this online regime. Please, if you have any questions, since this workshop is similar, if you have any questions, just turn on the microphone and ask your question, and I will answer them. So now I am presenting the screen. Yes, the entire screen, since I will need it. And we are starting with building, with a starting new project in IDEA. I use IntelliJ IDEA Ultimate because it is help. I will have to do a part in JavaScript, and it's helpful to have those capabilities. But of course, you can do it in a community edition as well. So I'm creating a new project, and I want to build a full stack web application, since we will be using both. We'll be using both backend and front-end part. So I'm going to call it like Jupyter plugin example. And I need to select a JDK. I use Gradle, but it doesn't matter in this case. So I'm clicking next. And I will have a common model, JVM model. I can use switch versions. I do not need a Java. I think okay, let it be the web server. I maybe I will use it. And you will choose a GS, IR. I do not need that CSS support. I don't think I need anything else. JavaScript is just a browser application. And I will use Kotlin XHTML. I think maybe I will use it. So I'm creating the project and a new window. And now we have it, and I'm switching into the presentation mode, so it would be easier to see what I'm doing. Oh, now I have a common module, JS module, and JVM module. We will start, of course, with the JVM module, because for starters, I want to create a simple plugin without a JS part. So for that, I will create a new file. It's called Kotlin. It's indexing. While it's indexing, we can switch to the site. I mean, to the Kotlin Jupyter site here. Oops, it's not correct one. This correct one. So what I will need to install the notebook itself. If you did not do it already, it could be done easily. You just go to this Kotlin Jupyter repository, and here is a simple installation link. Of course, I assume that you already have Conda. Otherwise, you will have to use pip or any other Python packaging. In this case, I just copy the link. Now I'm going here, and I'm creating here a new directory called notebooks, because I will create my notebooks here. And here I use, I don't remember how should I call the terminal. Okay, maybe terminal. I use a terminal and I go to the notebooks and I run this command. I copy it from the site. In this case, it won't do anything because I already installed the latest version. It is important to use the latest version because there are quite frequent updates of the Notebook API as well as Notebook plugin. So some new features are only available in the latest version. So be sure to use the latest version right now. It won't do anything because I already have a latest version. So now I want to create my plugin. It actually is quite easy to do. For that, Ilya done a simple example here in the same repository. And it's here, it's API examples and getting started. So I'm going here and I see what I have to add into the my build. Actually, I have to add this plugin. It's called Kotlin Jupyter API. I copy that. And I also need to know the version. For that, I can search, for example, I can search the Maven Central repository. Maven Central search. And we are going here and we can code Jupyter API. And here it is. There it is. Oh, the latest one. So we have the version, and I can copy this as well, or I can. Okay, I will copy the plugin declaration from here, and I go to build my build file and add. I actually do not need the application plugin because I won't do any console application. And this one is also not needed because the latest Kotlin X HTML is on the Maven Central repository right now. And gcenter does not work anymore. This one I can also replace right now by. Okay, now it's look more or less fine. And let's check the version is correct. It's not, so it could be this one. And we are adding this plugin here, and we need to add version. For that version, we are going back to here and copying version. That's all. Now we doing the Gradle Sync. Oops, something went wrong. I'm not sure what's happening. Oh, let's do it again. I'm not sure what the problem is. I can play safe and use the older version of the plugin, which I use, for example, in this Vision Forge project. Here I use the older version, and we can try that. And see if it works. Nope, something went wrong. let's see if something broken with the build. This one should not be here. No, still. Maybe there are some kind of problems with all this additional stuff created by the generator, by the Gradle project generator. Let's see. No, I'm not sure what happens. Okay, for now, let's switch to the project where it actually works fine, and we will see if something changes here. Here, it's a VisionForge repository, which is publicly available, and here I load the project on the global settings Gradle. I just declare the version, and then here is the actual build file which uses it, and it should just work. It's also the multi-platform project, and it loads just fine. Let's maybe try to declare it in the settings the same way. I will clean up all unnecessary stuff. This one we don't need, and we need only these and these, and we will need the actual version. Let's try it. And here we do not need versions anymore. What happens?
If I miss this kind of issues, I am sometimes running Gradle command from the terminal. Then you are
yes, right. Yes. Let's try to fix it by using the terminal. Maybe it's just a sync problem. Oops, wrong directory. Oh, sorry, it won't work. It's frustrating. It's also possible that Gradle version is wrong. No, it's okay. It should work fine. Strange. Something's broken. Okay. No, it should work just fine. I can remove all those things which are necessary, and it still should just work. And it does not. I'm not sure why. Okay, let's then maybe switch a little bit and turn to the project where it is actually working. So maybe then we'll return later and see what went wrong in this project. I'm not sure. I do not see any problems here. Let's switch here. And here it actually works. So I'm going to Gradle window, and I can just run the project, which is working. And it works fine. And while it builds, let's see how does it work. It's actually exactly the same. I'm not sure why it does not work in the former project. I have this plugin applied, and it both adds the library to the Jupyter API library, and it adds a capped plugin which is able to detect the Jupyter integration wrappers and add them. And here I have a Jupyter integration class. So the only thing I need to make an integration from it is to use this Jupyter library annotation. So in this case, what we will need to add new things to our plugin is to define some things in this override function builder onloaded. We can actually try to recreate our project by using only JVM target. Maybe it will work better. Let's start a new project. And we use a JVM console application, and let's call it Jupyter JVM. It should be fine. The coordinates are okay, and we won't change anything here just to be sure. And we will create a new window. Okay, it started. Now we're doing the same. We are removing this application thing, and we are adding Kotlin Jupyter API and adding the version from Maven Central Search. Moment, please. I can see your comments without switching. Yes, the Gradle is not that complicated, but it's frustrating for people beginning to working with it. Okay, in this case, everything should be okay. And I have to remove the application clause because I do not have an application. Okay, now it works. I'm not sure why it did not work in the JVM or in the multi-platform application. So we will return to that because I wanted to show you exactly that. I wanted to show you communication between the JavaScript part and the JVM part, but let's start without it. So we are going to main, and it doesn't matter what we have here. We are creating new file which will make our integration. Let's call it, I don't know, my Jupyter, or example, Jupyter integration. I'm creating the class. I can make an internal to internal in order to example. And as I said, I need to inherit it from the Jupyter integration. Jupyter, here we are. And I need to annotate it with this annotation. If I am doing it correctly, let me check. Yes, Jupyter library, so it's correct one. Now all I need is to implement one single method which is existing in this class. And in this method, I actually add things I need to implement inside my plugin. Let us do everything in one single file. So, for example, we want to render arbitrary HTML code without writing HTML as a string. For this, let us load this Kotlin X HTML library in the build. So I'm returning to the build here and adding a Kotlin X HTML library. Implementation org JetBrains next HTML, and the version I remembered by heart, it's 0.073, so it should work right now. Yes, it's working. Okay, fine. So now what I want to do is create a new object which will contain the HTML code. For this, I'm doing like class HTML content. And what I will have to do is to implement it as a function, because HTML is a library which allows appending things to HTML. It does not store the HTML tree itself. So I'm using a function here, val builder, say flow or tag consumer, whatever function, and here is my HTML code. And now all I have to do is to allow rendering this HTML. For that, I add the function here, render, and HTML content. And here, this function allows me Jupyter automatically to render when I have a HTML content as an output of my cell. It allows me to automatically render it as an HTML. For this, I call the internal HTML function, not this one, but this one, which will consume a string. And there is an additional option which allows to add a self-contained HTML. Right now, I do not need self-contained, so I only have to create a string. In order to create a string, and it's an argument of this method, and I just use create HTML and apply content builder and finalize, which produces a string. That's all. That's all. So I create a HTML root, and create HTML creates a tag consumer which consumes a string. then apply this builder, and you can see this builder is universal. It does not know that it applies to a string. It could apply the same way to the DOM element. And then I call the finalize, which produces a result of this HTML. This is mostly all I have to do right now. So the only thing I want to add here is to be able to use this HTML content without import. In order to do so, I can use several methods also provided by the Jupyter integration IP. Import, import. You can see there are two methods here. One allows you to provide explicit import like I do in this Kotlin files, or I can use a type of method inside and just pass the actual reflection class here. Like let us do this this way. HTML content. That's all. Now, my first Jupyter integration is done, and what I want to do next is to publish it and use it. The best way to do so is to publish it to any Maven repository. Why it's important? We can of course, we can do a fat jar, one jar integrating all our dependencies in here, like Kotlin standard library, like the Jupyter API, like everything else, like Kotlin X HTML, for example. But it's not always productive. In my opinion, it's much easier to just publish these plugin to a Maven repository, which will govern all the transitive dependencies automatically. And for that, I have to add a additional plugin to my build, and I'm adding a Maven publish plugin. Maven publish. That's all. I'm doing a sync here. It is done. And now, if I open this Gradle panel and see tasks, I will see a single additional task, which is called publish to Maven local. And I will just run it. That's all. It's published. So now I can go to my browser. Sorry, it's maybe too small for it. And I will look into M2 in my user home and the M2 directory, and here I have repository, and I have ru mip npm. Oops, it's the wrong one. Sorry, I'm not sure which project. It should be in this here. Why it is not published? Let's just clean it up and do it again. I'm just deleting it. And I'm publishing it again. Yeah, for some reason it doesn't generate anything. Why? Why is that?
There is no build folder in your repository, so there is nothing to be published. There has to be jar somewhere in the build subfolder in your project.
No, there should not be. It should just create a library from it.
You have not set up the publication. Maybe.
Yes, it's not because the problem is that I forgot that for multi-platform, Kotlin automatically sets up the publication. If I use a Kotlin multi-platform here it automatically sets up the publication. If for you are quite correct for regular Kotlin GVM target, it does not create a publication. I'm not sure I remember properly how it is done. Let's try. Had to remember it by heart. Okay, let's go with a simpler. I probably will never again do something without. Let's just copy a code. No, that's a multi-platform library. Okay. Here there should be a publishing script somewhere. Pity. It has a jar, but not. Getting. We can, of course, we can use a fat jar. Okay, let us do a fat jar. For that, we have to use additional plugin, which is called Shadow. And it's also quite simple to apply here. So I just have to add this line again to my build, and I'm not sure it is friendly with the Jupyter plugin API, but let us try it. Again, I'm syncing it. What happens? It's too new. We can upgrade Gradle. What happens today?
You might try to use the code snippet I've sent you in the chat.
Okay, let me try. Thank you very much. Aha, okay. Thank you very much, Leah. I have not worked with I have not actually worked with non-multi-platform projects for some time, so and I should remove the shadow plugin. Okay, fine. Let us try again. Now we are going back to this Gradle, and we actually doing publish to Maven local. No, we need. We can use any of them, and now it does say anything, and you can see that actually does some additional task. For example, it generates this task is important because it generates additional resource file, which will be then used by the Jupyter kernel. Let's see if it is generated correctly. Well, first of all, let's see if it is in the repository. Yes, it is in the repository. We can see that there is my file here, and we can actually try to look inside this jar file and see if the resource file is generated correctly. For this, we go into Kotlin inside the meta-inf Kotlin Jupyter libraries, and here it is, the libraries JSON file, which includes very important line here, the reference to our integration. Brilliant. Now all we need is to start the Jupyter and load us our plugin. For this, again, we are creating new directory, notebooks, and we are going into the this directory, and we are starting Jupyter lab. And it's starting, and it is started. Now I do not see anything in this directory, so I have to create a new Kotlin notebook, and I'm creating it. And here we are, and we can write something here, and it will be the kernel is starting, and now it is computed. But what we really want to do is we want to load our plugin. For this, we have two ways. There is we can load the descriptor from our library into the central Kotlin Jupyter repository and wait for it to be accepted, and then use directive like this one to load it, but it takes a lot of time. A much easier way is to actually load it from our local storage. For that, we first have declare the repository, and we use a repository annotation, and we use Maven local file. We need to add file here, otherwise it won't work. You see, it's not a Maven local, but it's a star Maven local. It's a special shortcut to use a Maven local, and it is documented in the Kotlin Jupyter repository. Now we use depends on annotation, and here we write the Maven coordinates of our repository. It will be root mid npm and whatever I called the repository. I don't remember. It should be here. Use a colon for separator, and the version, again, I need to take a version from my build file because it's the version used for resolving. Okay, I run it. Something happens here, you see, and we can track the progress. No errors, but we can actually track the progress here, and we can see what happens inside in the log inside our notebook. It's a lot of letters here, but mainly it works. And now to finalize all the things we need, we want to add our code here, and we're starting to use HTML content. You see, it's autocomplete. I haven't wrote these lines, so it's autocomplete, and it works. Of course, if I start, I can use empty content here without anything, and it will display the blank line as expected. And I can use HTML content to try to write some kind of code, but it actually won't work because I forgot to add something. I forgot to add input for Kotlin X HTML here. I can do it right now by adding import in the notebook. Import Kotlin. I don't remember correct path for it, so I will just again look into the code and copy it. So what I want to probably is to use Kotlin X HTML dot star. Kotlin X. I can use autocomplete here, and I can see a lot of things here. And now it works. You see, I've added import, and it recognizes div, so I can use, for example, p plus hello Kotlin, and it works. Oops, my mistake. And I can replace it by h1, and voila, we have a full HTML support here with a type-safe builders, because I can even use autocomplete here. You see, it's quite convenient thing to do. Of course, we probably do not want to write those things here. So in order to remove it, we copy it and we go back to our plugin here and add additional import. That's all. And we are doing publish to Maven local. Okay, again. Oh yes, it's the file is locked, so I need to restart kernel here. So it unlocks the file, and I need to run it again. What's happening? It is locked, so stopping kernel. Restart. Right now, I will just use it, do it like this, and it will work. I will change the version. The problem is that Ilya switched the resolver, quite recently switched the resolver from Ivy resolver to Maven local Maven resolver, so we are not fully controlling what happens right now. So we do not tested all the possibilities with the Jupyter plugin. So I am doing this one, and it will load the new version. Now I'm removing this additional import, and I'm doing this, and I'm doing that, and it works without imports. Brilliant. So this is our first Kotlin plugin, and it works right now fine. And I can show you, if you want, I can show you examples of much more complicated plugins. And if you have questions, please ask them now. But what I wanted to show you today also is a more complicated thing with the interaction between the backend and frontend. And for that, I would like to make this thing work. I'm not sure why it does not work. Right now, you can ask questions if you want. Not sure why it doesn't work.
Maybe I have just a little off-topic question regarding usage of Kotlin Jupyter kernel with the virtual environment. What are you using, Condas, or are you working with VNVs?
You actually do not need environment in Kotlin Jupyter, because the only thing you need from Python in order to run Kotlin kernel is the plugin itself. So you launch plugin, and then all the repositories. I'm not sure you will be able to see it. Font is small, but all the dependencies you do are not stored inside the Conda or Python or whatever. They have a separate repository here. It's a Maven local repository, and it stores different versions. So you can see right now we will have 2 versions of it, snapshot. And what Maven does, it does not have an environment. It loads appropriate version when you request them. And
this is clear. Thank you very much. But the use case that I'm asking for is usually you have projects where you are combining different notebooks. So the question is, if it's possible at all, or it doesn't make sense. You have a project with Python notebooks and Kotlin notebooks in the same place. But this is really a corner use case. So let's keep staying Kotlin.
It's just the only dependency from the Python ecosystem is the Kotlin plugin itself. So you can have it in an environment. It depends on from where you launch this Jupyter laboratory or Jupyter Notebook Classic. You do not have any other dependencies from the Python world.
Okay, thank you.
I'm not sure where this year comes from. Right now, I should probably remove this version because it's already in the settings. Okay, in order to save time, we will probably should look inside the implementation inside the Vision Forge, because it's much more complicated than the one I wanted to show you, and maybe we'll save time on this problem. It's some kind of a build problem, and I'm not sure what causes it. Or I will investigate it later. So we will switch to the Vision Forge, and we'll see the plugin for ourselves. Let's see. Here we have a lot of projects. Vision Forge is a huge framework for visualization of different kinds of scientific data, and its current primary goal is a 3D visualization for events in the accelerator physics, etc. And let's see into the plugin I've created for GDML, which is a representation for 3D geometry in the Geant4 software and Geant3 and the Geant4 software used in particle physics. Let's see the plugin itself. You see also already familiar things like import a lot of things from Kotlin HTML, like from Vision Force itself, like in the GDML converter, and they have several renderers for different objects I have here. And there is important addition to all these. This is the resources class here in Builder, which uses the GS file provided on the class path, which means it's a part of the resource bundle. The resource bundle itself, we can see how it is generated. It's actually generated from the same project. It's a multi-platform project. So I have a GS and GVM part here. And if I see the build, I see additional customization of the build, which allows us, specifies explicitly the name of the GS bundle provided by the Kotlin GS. This one you can ignore. It's just for compatibility with some libraries. And additional clause here is also important. It puts the JavaScript bundle into the resources of the GVM target. So what I'm doing here, I want to state again. I'm finding the task which produces the GVM resources. Then I find the task which produces JavaScript browser distribution, and then I copy the data. Actually, there are mistakes. Is a double after evaluated should not be here, but I copy the data from the browser distribution inside the GVM resources. Let us run this task and publish this project to the Maven log. And meanwhile, I will explain what happens in the GS part here. And for that, I again run the Gradle tool window. And here I have this Jupyter. Inside it has a GDML and publishing, a lot of publishing. Here I publish it to the Maven local. It will take some time because the project is large. Oops, some are coming. So while it's building, let's see what happens inside this GS part. On the GVM, I already showed it. It's simple as that. It's just this integration. But on the JavaScript part, I have a main method. I mean, this part will be run when I start then I load the resource. What it does, it loads some parts of the Vision Forge framework, but what is important here, it actually adds a hook. It's not a very good thing in the Java world to do a monkey patching of objects, but sadly, right now, there are no other ways to do that. So I add a render hook into the window object, which is accessible from a JavaScript. It takes current JavaScript environment and adds a hook with a given name, which refers to a given function, also registered in the written in the Kotlin JS, which allows us to find all elements with the proper classes and render the data. I always forget the, oops, a lot of people late by an hour. Maybe again, the meetup time difference represents time wrongly. I think they expected it to be European time, not the Moscow time. Where am I? So let's check if the Gradle build is completed. Yes, it is. And I have, you see, I now have 3 new artifacts in my Maven local repository. Let's just load them. So we are going again to our Jupyter window, and this repository is the same, but now I'm loading different methods here, and I'm loading, it should be space, science, I don't remember the name, so I will just copy it. And also, I do not remember the version, so I will copy it as well. It's a development version, so this one I will use. This GVM postfix is important because it's a multi-platform project, and current resolver, it's not a Gradle resolver, it's a Maven resolver, so it doesn't know about Gradle metadata. So if I skip this prefix, it will load the wrong artifact. So this one is important. When you write in the Gradle, it's not important, but here it is. Okay. Aha. The problem is that I've published this project alone. I did not publish dependencies. Okay, I have to publish the whole project, otherwise it won't work. I hope it won't take a lot of time. Okay, while it's loading, I want to add another example. It's a Plotly Kit library, which also have some additional features, not even present in the GDM, in the Vision Forge. Let's see here. You see, here we have a Plotly server library, and we can see the integration here, which is also quite like the one I've presented you already, but it's a little bit more complicated. And we have resources, we have imports, we have renderers, and we have some additional things like loading, doing some work on when the plugin itself is loaded, and cleaning up resources when the plugin itself is unloaded. But what is more important, it allows to communicate between the server, between the plugin itself and the web view. I will show it a little, still building. We can, I think we can play with it right now by using this use directive. For some reason it uses old descriptor. Why is that? I'm not sure. Okay, let's try it this way. File. Have to wait for some time until it loads. Aha. Yes, this is a problem with the repository, the Kotlin CSS repository, which is not required. Actually, I removed it. Let's fix it. You see, now I have some kind of message which run on the start, and I will in short, I will explain what I've done here. And now I'm doing I have this plotly object. I can do a plot. And you see the plot works. It's as simple as that. So it's just loads a plotly library. It loads a plotly library, and then I'm just writing this without any imports and without any additional parameters. But what is more important, I can do modification. And I'm creating this plot. Plot, not plot. And now let us do something more complicated. I should use serve, not plot. Yes, it works. Fine. So you see, I am changing something here, and it's changing in the picture. It's not quite as simple as it looks like, because what happens under the hood? You see, I've started a separate Ktor server here, which uses a WebSocket communication and sends updates to our front end here, writing on in the Kotlin JS, and it updates the picture on the JavaScript side on the client. This one is not as easy to do as it's as to just write your plugin, but still it does not require a lot of code to do that. You see, all I have to do is to create a backend, I mean the Ktor server, which does that, and then create a front end which receives the communication and changes things. We can see it here. And for example, the client part, it's in here in JavaScript. And it's not that complicated. It's actually written in JavaScript. For Plotly, it's actually written in JavaScript, not in Kotlin. Here it is. So this is the front-end part, which receives the message and change things on Plotly. I will skip to it. And here it is. Here it is. So you create a WebSocket and then write some code which receives the message and updates the specific plot with content. Since it's a WebSocket, it's a bidirectional, and you can both send messages to the front end and receive messages from it and update the backend part. The server part I can show you as well. It's Plotly server here. So here it is. It's a you can see it's actually it creates some additional JavaScript parts in order to properly load pieces, but in general, it's just a quite simple Ktor server running WebSockets. So you see it receives a Ktor routing and then serves WebSocket updates on it using, of course, using coroutines and using message streams. It's a much more complicated example than the one I wanted to show you, but since there was some problems with the build, I can show you the one I wanted to do initially. So probably I won't be able to explain the whole code part without your questions. So if you have questions, please ask them. And of course, maybe if you are interested, we can in future create some kind of library which allows to automatize this communication between the front-end part of this Jupyter plugin and the backend part. There is a problem there right now. Everything works more or less fine with the Jupyter lab, but does not work with the Jupyter Classic because of the problem of dynamic loading of JavaScript parts into the Classic. But I hope that people from Kotlin for Data team will solve it in future. So if you have any questions.
Sorry, it takes always a few seconds for unmute. Just to understand what we are doing, you want to show in plot dynamic data coming via WebSockets, for example, dynamically from the server, kind of type of dashboard, right?
It's full. The request people usually make to do in Jupyter is some kind of widgets. When you can propagate the state from the code to your widget here, and I showed you already. We can do, for example, we can do it like. We can move the data from here, or we can let's try something. Probably you will like it. We can change this data dynamically. For example, global scope. We can do things like that. It will require additional import from. Yes, I need to import coroutines for it. And I need to import random.
So it's more about being the dynamic as having communication with some backend, right? So it's just
yes.
source of data. It's not about communication with backend, of course, but it's more about being able to update HTML cell with the new data, right?
Yes. So okay. When you're working with a Jupyter, you need to understand that what you create here, any interaction here, it's done in the front end. So it's on the JavaScript or Kotlin JS or TypeScript or whatever language you use to cite. I'm not sure. Does anybody remember the proper import for random? We can do just counter.
Kotlin random.
Ah, okay.
Yes. Second try. Yes. Mhm.
Yeah. Here it is. Okay. So we have, in general, if you want to do a widget, you need two things. You need to update the state of your front end from the backend, like I've done right now. And you need to update the backend state from the front end. So you need to evaluate messages from your JavaScript and send events back to the backend. And right now, it's simple thing to do, because if you have, for example, a WebSocket communication, you can do it both ways. So yes, you can implement things like IP widgets from the scratch in Kotlin without using IP widgets API. The only complicated thing right now is to actually load this JavaScript and make it recognizable from your load the JavaScript part when you load the plugin itself. It is handled by this resource, new resource API right now, but you still have to add these main methods and add some kind of hooks into the window in order to do it properly. Okay, I think for today we're out of time, and please tell me if you want some more hands-on experience workshop like this in future, maybe more prepared this time. I had not expected this bug with a multi-platform build, because I've done it before and it worked fine.
I am completely newbie in that field. For me, it would be really useful if you make your simple sample running, just publish it, because there are so many steps and I got already struggling on the beginning. So I could follow what do you mean with these hooks and windows and dynamics features, but I have to go through to learn the basic things first, like publish to the local Maven and so on. So having this basic starter would be very helpful. And if done this, it could be interesting to learn more about more advanced things. But I guess I will be quite busy now for a few days, weeks, to get this Hello World working.
I will publish the code of this plugin I've done here. It's pretty simple. I do not think we need this one. So this simple code, like you see, it's like 10 lines of code. If you do not want to do communication, that's all you need. You can add anything you want here, any HTML. You can add external JavaScript libraries here and use them as renderers, of course, only in the Jupyter lab, etc. So this is the whole basic example, and of course the build file with the publishing.
But this is very useful for the beginning, for the start.
Yes, so I will publish this code. As for communication, it's a little bit, but not a little bit, it's more complicated, because you need to create a server. Like I use a Cater server, but you can use any server you want. Then you need to use a front-end connector, which will connect to the server and update the data on the client side. And this connector must use a WebSocket or any other way of push notifications. And then you need to create some kind of common code for example, for serialization of the data you are transmitting. And then it will work. I'm not sure it could be done easily by a beginner, So maybe we'll. Oh, yeah.
Yeah, I wanted to add that you actually, if you don't have to send messages from server to front end without the requests, you may use on update callbacks in Jupyter integration. In your display objects can have IDs, and then you may update these objects using the IDs. So
I didn't know about that. We should probably maybe you should give the next tutorial because it's quite interesting, and I've done those IDs myself. So if you see this code, for example, it's hard to read because it's a lot of code, but here I've actually this counter, this is used to create a unique ID. If you already have those IDs, it simplifies things.
And this API allows to do the first part you showed about changing title of the plot, but it doesn't allow to amend the dynamically.
Yes, I mean push notification. I think it would be interesting, and my opinion is Jupyter Kotlin is a great tool not only for doing some scientific prototyping, but also for beginners in Kotlin, because as you saw, when you're not doing your plugin, but simply using something already existing, it's as simple as that to load your library without any Gradle, without anything, and just work with this Kotlin code. And even do some nice things like plots.
One question to this communication connector, is this kind of background process you have to start it from your Kotlin code, or it's
Yes, it's exactly like this. You can see here this line. It's a started plotless server on the port. So we can go to this port, like in local host, whatever.
But on the front end side?
Yes. I don't remember. I need an ID to connect to it. But generally, yes, we have a separate server running because the communicate. I think Ilya will cover it in one of his future talks, because the communication between the Kotlin kernel and the Jupyter itself is done by a different channel. It's done via 0MQ between the Kotlin kernel itself and the host. I mean, the Python process which hosts the notebook itself, and then from this host to the client. So it's pretty restrictive. We can't pass arbitrary Kotlin data through this channel. If we want some kind of our own interactiveness, we have to use our own separate server. By the way, the Jupyter IP widgets work exactly the same way. They create a separate server for that. They do not use internal procedures of the notebook. Okay, I think we are quite out of time, and probably we will be doing more such tutorials and discussions in future. And a lot, of course, a lot of things to cover, but at least you will be able to do your simple plugin right now without communication. and in the future we will continue to do so. Thank you very much, everyone who attended. And of course, thanks a lot to Ilya for doing all these APIs available, because without them it would be much, much harder to do.
And to Anatoly Nikitin.
Yes, of course, to the whole Kotlin for Data team.